Hello, this is Dr. Strickland. In this video, we will investigate the nomenclature of alkynes and polyfunctional compounds. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. So we've done a lot of nomenclature so far, and you know already that an alkyne is a hydrocarbon that contains a carbon-carbon triple bond. So the first thing I wanted to do is to kind of put this in the context of the nomenclature priorities that we already have. And in general, an alkyne has about the same nomenclature priority as an alkene. Now we'll have some clarifications on, what happens if they're in equivalent positions, but we'll take care of that in a minute. But in general, it is not as high a priority as an alcohol or an amine, and it is a higher priority than an alkyl group, an aryl group like a benzene ring, a halogen, an alkoxy group like a methoxy group, or a nitro group. And so the basic rules for naming alkynes are very much like what you remember from naming other things. You got to identify the parent, which is the longest continuous carbon chain containing the functional group with the highest nomenclature priority. A carbon-carbon triple bond always involves two carbons of the parent. You're going to number the parent so that the alkyne gets the lowest possible numbers. To show its presence in the name, you're going to change the ending ane to yne, which is pronounced "ine," and use the lower of the two numbers that you got up here. And then alphabetize the other substituents just like you normally do. So it's important to be able to go from a structure to a name or from a name to a structure. So we're going to do one of each. Now I found my parent, which contains the two sp hybridized carbons of the alkyne, and I numbered it so as to give the alkyne the lowest possible number. And so this parent has 7 carbons, and it has a triple bond in it. So it's a heptyne with a triple bond at carbon 2. So I'm going to build this name from right to left, putting the parent in and its functional group that has a suffix. And then I can see that there are a couple of methyl groups attached to carbons 5 and 6. So this is 5,6-dimethyl. Now you don't have to assemble your name from right to left. I'm just doing it this time just to show you, that we do the parent first and number it, and then we attach stuff. And then if there were any stereochemistry, it would come further to the left. Okay, so over here where we start with the name, we've got 1 pentyne and we've got 1 asymmetric carbon. And if you only have one place of stereochemistry, it doesn't have a number, just just says whatever it is, like an R or S for an asymmetric carbon. If there's only one, I think it's a great idea to use a perspective formula. Now you don't have to. You got a couple of other options to do that, but that's what I'm going to do this time. And so I'm going to set up my asymmetric carbon with 2 straight lines in the plane of the paper, a solid wedge pointing out towards us, a dashed wedge pointing away from us. And I'm also going to do a sketch here, just to kind of get an idea of what's connected to what. So 1 pentyne, if I start my numbering on the left, that would look like this. And then there would be carbon 3, 4, and 5. And I know that I've got a chlorine at carbon 4. All right, let's put the hydrogens in. We don't need any more there. We need 2 here. We need 1 there. We need 3 here. And I can see that this carbon 4 has the chlorine substituent, actually has 4 different things attached to it. So this is where the asymmetric carbon is, and this is where it will have to have the S configuration. Okay, so if I know that, I can go ahead and do the priorities of these 4 things that are attached to the asymmetric carbon. So a chlorine, 2 carbons, and a hydrogen. So this has the highest priority, and this is the lowest. And then looking for the first point of difference, this has 3 hydrogens attached to it. This guy has a carbon and 2 hydrogens attached. So written in order of decreasing atomic number. And my first point of difference is right there. That tells me that this is B and this is C. All right. Now, when I'm assembling a name, I think the easiest thing is to put the group of lowest priority back, attached to the bond that has the dashed wedge. And then if it's supposed to be S, then S would be counterclockwise with the group of lowest priority pointed back. So for me, I think it's the easiest thing to do is to put the group of highest priority here and then just go around counterclockwise. So that means the chlorine goes there. This part that has a triple bond in it is going to go here, and you can draw out those single bonds a little bit if it helps you space it. Just make sure that this carbon and that carbon are attached by a sigma bond, and then the methyl group is here. Okay, and so that's how I would tackle it. There's probably other ways, but I think if you need a system, I think this is a good one. All right, so what happens now if you have a compound that has more than one functional group? We sort of started that here with the chlorine, but these things that are in the lowest possible nomenclature priority, as far as I know, are always represented by prefixes. And we're talking about the ones that are represented by suffixes. So if you come up here, the ones that are represented by suffixes that we're dealing with now are alcohols, amines, alkenes, and alkynes. So this set of rules comes from our text, and it's focusing on when one of the functional groups of the two or more is a triple bond, but it doesn't have to be. And so these rules can be generalized to cover any polyfunctional compounds. And in fact, the two that we're going to do down here at the bottom of the page, neither one of them has a triple bond in it. So I want you to see how that goes. So if you're going to name an alkyne in which the second functional group is not another triple bond, but has a functional group suffix, like an alcohol or an amine, or a double bond, you find the longest continuous carbon chain containing both functional groups and put both suffixes at the end of the name. The YNE, the ine, is going to come first, with the terminal E omitted to avoid two adjacent vowels. The one exception to that is if your second functional group is a double bond, ene goes before ine. And so you just have to know that. All right, the number indicating the location of the first stated functional group is placed before the name of the parent. The number of the second is placed immediately before its suffix, and we'll see that. If the two groups are a double bond and a triple bond, you number the parent in the direction that produces the name containing the lower number. Because remember, they have approximately equivalent nomenclature priority. But it's possible that when you do that, you're going to get the same number in both directions. And in that case, you break the tie by numbering the direction that gives the double bond the lower number. Okay, so this last one, I think, is the most general of these five. If the second functional group has a higher priority than the alkyne, you number the parent in the direction that gives the lower number to the functional group with the higher priority suffix. And that's true for any pair of functional groups that get represented in a name by suffixes. So we're going to do a couple down here. And take a look at that. So what I did was I went ahead and picked out the parent and numbered it. So you can see we've got an OH, an alcohol, and we've got an alkene, a carbon-carbon double bond. And since the alcohol has a higher nomenclature priority than this carbon-carbon double bond, it gets a lower number. So we also have one place of stereochemistry to deal with, and that has to do with this double bond here. And so it would be a good idea to just go ahead and mark that we need to know what the relative priorities are these guys are on the right and those guys on the left. And so when you do your priorities, this one is the higher priority of these two, and this one is the higher priority of those two, which makes this Z. Okay, so if I wanted to just go ahead and name it left to right, we'll do it that way for a change. The stereochemistry comes first, no number, because there's only one place of stereochemistry. And see, we've got a bromine attached to carbon 4. and then the double bond and the alcohol will be represented by suffixes. So the number for the double bond comes before the name of the parent, so that's 3-hexene. We drop the final E because the OL is, we'd have the E bumping up against another vowel. And I'm going to go ahead and put the number in, but you wouldn't have to because this location number, locant, is a 1. Okay, so Z, 4-bromo, 3-hexene, 1-ol. All right, so what if you're going the other way? You've got a parent that's a cyclopentene, and we don't have any number indicating the presence of the location, of the double bond, so it's got to be carbons 1 and 2. So we'll just go ahead and put that in. 1, 2, 3, 4, 5. Okay, we've got a methoxy group at carbon 3. So that tells me that, since this is 2 hydrogens and that's 2 hydrogens, neither one of these is the asymmetric carbon. These two are sp2 hybridized. So they can't have the R. So it's got to be here at carbon 3. And so I've got a methoxy group to place and a hydrogen to place. And I think it's a really good idea to do these in pencil because then I've got some flexibility. And here, I want to show you what I mean. So let's say I wanted to put the methoxy group here and the hydrogen there. Okay, so I know that the hydrogen is going to have the lowest priority, and the oxygen is going to have the highest priority. And then we've got a couple of carbons, and you can go through and do the analysis. It turns out that this way is B, this way is C because of the carbon-carbon double bond, because this carbon is attached to 2 carbons and a hydrogen, and this one to 1 carbon and 2 hydrogens. All right, so if I do this A to B to C, this is counterclockwise. With this would be S, but I don't want it to be S. So to switch it to R, all I have to do is change those 2 places. And this is the great thing about working in pencil. Okay, so this is group of highest priority. This is the group of lowest priority. I can take this out because I've finished with that. I'm pretty sure I've got it right this time. A to B to C is counterclockwise with the group of lowest priority pointing out. And that is R. Okay. All right. So that is the basic story on the nomenclature of alkynes and polyfunctional groups. Polyfunctional compounds. If you have any questions, please send them to me.